everyone, this is our last progress report video for our chatbot before our final demo video. So let's get into it.
First, we're going to talk about our front end. Our front end is still built on the basis of what we had last time, but this time we have some significant change. Now, when a user is typing in a question about a course material, say we want to add a new question. Let's say the user wants to know what are macromolecules. Last time when we did the front end, it was only able to display some results. They are like text only. But now if we click post, we will see that our front end has a lot more new features than last time. Now we see that it's not just text response anymore, but we also get a embedding of the PDF file. And it is actually taking us to the specific page that talks about the topic that the student wants to know. So he doesn't have to scroll through the entire document to find the information that he needs, but the chatbot is like providing the index of the page for the student. It is also providing a video for the student, and it also takes the student to the timestamp where the video talks about the question that he wants to know. Because like some videos might be really long, some lecture videos might be hours long, and when the student is only wanting to know about like a very detailed specific topic, it makes sense for the chatbot to take into like the exact timestamp where the video talks about it. It's nice that we have the YouTube and like the PDF thing embedded into our response, and now we're going to jump into the code to see how we did that. This is the component where we display all of our details for discussion. On top is the logic for fetching the data from the backend. We can see that we have these two iframes. One iframe is for the YouTube and the other iframe is for the PDF. And we can see that we have a conditional display. So first we're gonna check the data from the backend for the length of two variables, book source and YouTube embed link. If we get a response that contains a link to the video, then the YouTube embed link is gonna have a length more than 0, and it is going to display the YouTube video. And if not, it is not going to display it, so that we can like make sure when some response doesn't really contain a YouTube link, we won't be like including the YouTube link by mistake. So like these two conditional rendering is like making sure that we can display the video and the PDF based on what question was asked and what the response is wanting the student to see. And this is like the two main difference that we have made to our front end so far.
So yeah, this was the front end, and now we will be showing the back end and how that connects. So the back end is running with the server.js, and server.js outputs whatever our Python script it outputs, and usually it would output the content, which is the response of the chatbot, any YouTube link and a YouTube time for the video, if that response includes a video time, and then the textbook or lecture source, as well as its page number of said textbook or lecture source. This is all connected with our chatbot.py, and chatbot.py actually contains a lot of different scripts for different functions of the chatbot response. So as you can see here, we have the chatbot response, the AI response here. Then we have the PDF output and the video output. And each of these are outputted from different scripts. Each script has a different output or different parts of the output. And so these are from our chatbot parts folder, and each of these code actually outputs what our response is going to be. So we've actually seen all of these code before in our previous demo videos, so we're not actually going to go into each of them, but their names are pretty clear. We have the YouTube video script that outputs the YouTube video if that was applicable. We have the PDF excerpt if there is a corresponding textbook or lecture notes. And we have the smaller scripts that searching for keywords in order to find them in the video or in the text, as well as the RAG chain that our chatbot uses to go through all of the documents that were saved in our database, our Milvus database, and finds like similar documents and then outputs the most similar documents out for us. As well as the connection to our Milvus database. We just split them up into separate parts to make it easier and to organize it. And each of these gets outputted into chatbot.py, which connects to server.js, which connects to our front end.
Hi, what I've been working on was trying to put deploying Milvus online. A lot of the parts about chatbot is trying different models, and a lot of these models are paid, so like we don't want to retrain them like multiple times. One problem we always encountered was whenever we train from these PDFs and these texts, we have to retrain it 3 times on all of our machines for the server to run, right? So instead of that, I thought of embed the PDFs and text and then push it into a server, which I did using GCP. And this is a GUI. This is a GUI for Milvus that is being developed by Zillis, the company who created Milvus in the first place. It's an open source, entirely free. I deployed my Milvus and this GUI called Atu in GCP. And currently I've trained one with Voyage and GPT-4. The one we're currently using is GPT-4, and if you click it, you can see the fields like sources and text and everything. You can also see what it looks like, what the text look like, and what the vectors look like. And this really allows us to change the embeddings, whichever model we want to. So let's say there's this leaderboard, the MTEB leaderboard, the massive text embedding benchmark leaderboard. And it's a very, very, very useful leaderboard to use to try to train to see state-of-the-art models and see their rankings. Certain tasks like classification average, clustering average, pair classification, retrieval, and summarization and other stuff like that. Using LangChain, we can click the first model that comes out. It's the Voyage Large 2 Instruct. Voyage is an open source free model that beats GPT in a lot of things. And an easy way to change it is there is already LangChain Voyage AI. There's already a LangChain Voyage AI built into LangChain, so you can kind of see. So you can just import it through Voyage AI embeddings. Go down here and change the collection name to something to let's say Voyage Large, right? And you can change the embedding model. Instead of OpenAI, you can use Voyage AI embeddings. Declare the model. You can run it through Python. This script will automatically add all the PDFs and all the text into a new collection. Before that, always delete this files inserted list into the database. So as we can see, it starts inserting the PDFs and text. Yeah, there you go. And you can see if we refresh the page, you can see that there's a new database currently being added in real time. This is all deployed in GCP in Google Cloud Platform. It runs a virtual machine and that's where all of this is being, and it runs a Dockerized container of Milvus and Atu. It will continually add it to this, add the source, the PDFs and text in and embeds it, and it will send it to this vector database. And then all we have to do later in chatbot.py is to go to ragchain.py and just change the collection name to whichever collection we want to use. Let's say Voyage Air. It works even though we don't have everything pushed in yet, but it might not be the best answer since not everything is in. But We could quickly just change it to Voyage AI. Get rid of this. And now if we want to just try another question, might not give the best answers since not all the files is already pushed in, but it should give us an answer. One thing we noticed when chatbot PY, it sometimes output the batch size and all, it like loads the model every time, so it's interfering with our model, but that's the database for now.
Thanks, that's all we have.